Hello students, here is another exciting or interesting case study we can see here. Case study says an open water tank of aluminium sheet of negligible thickness with a square base and vertical sides. So this is cuboidal in shape, but the thing is base is square. Here it's clearly written base is square. It's to be constructed in a farm for irrigation and it should hold 32,000 liters of water that comes out from a tube well. So question 1, if you observe here, length, width and height are mentioned x, x and y. So our box will be in this way where we will find that this will be x only. Okay, square base, actually it is now rectangular in shape, but we have to consider like this: length and width will be x and height will be y. Height will be y, and this tank is open tank, so that we should consider in when we will consider the surface area. Now since volume is given, so what we will write, volume of this cuboidal box will be, we know volume formula is what, LBH, isn't it? Length, breadth into height. So x into y, that means x square y, and volume is given actually 32,000 liters. So this also we have to convert into meter. Why? Because x and y are given in meter, y meter, x meter respectively. So 32,000 divided by 1000, if you will do, you will get in meter cube. So x square y equals to 32. This is the relation between x and y, and we will be using in different questions. Okay. So now first question, if you observe what they are asking, then find the outer surface area of tank in terms of x. Okay, so that means y we should write in terms of x. This y value will keep here. This y value we will be using in surface area formula for question 1. Now for surface area we know what is the formula. Surface area 2 into LB plus BH plus HL, isn't it? But L and B are XX, B and H X and Y we will take, H and L also X and Y. But the thing is here the tank is open. So instead of 2 LB, only 1 LB will come and 2 BH and HL side. This is open, no? So this surface won't be there. So what we can write, surface area, let's say let A denotes the surface area of tank. Okay, so A will be what? X into X, that is x square. I am talking about this base surface. Okay, then 2 times we will write BH means XY, and H is Y, L is again X, so XY. So finally we can write x square plus, here we will get 2xy, 2xy into 2 will be 4xy. But we should write in terms of x, so that means y value we should replace, and from where we will replace? From here. Okay, so A will be x square plus 4x into 32 by x square. So finally we will get 128, and this x we can cancel, 128 by x. So this is the answer for the first question. Now second question, observe the second question. We got the area as x square plus 128 by x. Okay, this is the answer for the first question. Now show that the cost of material will be least when width of tank is equal to twice of its depth. Now cost of material will be least only when surface area will be least. Okay, so what we will do, this is our function which needs to be differentiated with respect to x, and then we will find double order derivative of this just to check whether surface area is least or not. Okay, so dA by dx we can find x square derivative 2x, and 1 by x derivative of 1 by x, as you know already, it will be minus 1 by x square based on power rule. So 128 times minus 1 by x square. So 2x minus 128 by x square, this is dA by dx. Now to find critical point, we will equate with 0, put dA by dx as 0. So 2x minus 128 by x square is 0. 2x is equal to 128 by x square. So here clearly we can cancel from 2, right? 2 we will cancel. We will get 64. And this x square we can shift here. So x cube we will get 64. So x will be 4. So at this point we don't know whether surface area will be least or not. So that we have to check. So how we will check? We will find double order derivative. So this is our first order derivative, dA by dx. dA by dx is 2x minus 128 by x square. We will differentiate again with respect to x. So 2x derivative 2 minus 128 we will write as it is. Now 1 by x square derivative, we can write as x power minus 2. Then power rule of derivative we can apply, which will be minus 2, and 1 less in power means minus 2 minus 1, which will be x power minus 3, that is minus 2 by x cube. So minus 2 by x cube we will write. So it will become 2 plus 128 and into 2 will be 256 by x cube. Fine. So now we got 2 plus 256 by x cube as our double order derivative. So at x equal to 4 we will check whether this is greater than 0 or less than 0, and clearly it will be greater than 0. Okay, 2 plus 256 by 4 cube we can write, and then here you can cancel, or you can write 4 3 times you can write, then 1 by 1 you can cancel. 64, then here it will go 16. Okay, so 4 plus 2 8, which is greater than 0. So if double order derivative is greater than 0, by second order derivative test we can write, therefore surface area will be least when at x equal to 4. Surface area will be least. But we have to show cost of material will be least when width of the tank is equal to twice of its depth. That means width of the tank means x and depth means height, which will be y in this case. So we have to show x equal to 2y. What we will do, this x value we will substitute. We have our volume relation, right? We have x square y is equal to 32. So we will put x value as 4 here. So y value we will get 32 by 16, which is 2. So clearly x is 4 and y is 2. That means x is twice of y, isn't it? So we can write here, therefore if surface area is least at x equal to 2y, therefore cost of material also will be least at x equal to 2y, hence proved. Now question number 3 in this case study says, if cost of aluminium sheet is 360 rupees per meter square, then find the minimum cost. Okay, so actually what we have found that at x equal to 4, surface area will be minimum. Okay, so what is the surface area formula? Before derivation, deriving it, we got as x square plus 128 by x. So what we will do, this is the area, but at x equal to 4, this area will be least. So we will find that least surface area will be 4 square plus 128 by 4. So 16, and this we can divide 32. So 48 meter square is the least area, least surface area, and then cost for the construction will be, we can multiply 48 with 360. So we will get the final answer. So 17280 rupees will be the final answer for this cost of construction. I hope you understand this case study clearly. Thank you so much.